Welcome and good time of day, everyone. This is the Epic members' new product release, October 2025, and this is the session provided to you by Epic that shows you the most recent and innovative developments and new products developed by members of our industry consortium. Epic is the largest consortium for photonics industry in the world, comprises over 800 corporate members centered around Europe. And Epic is there to support you with technology developments, market intelligence, support in recruitment, investment, and business opportunities. So we have a very exciting agenda of Epic members today. We'll hear presentations from ficonTEC, HETEROMERGE, Inno-Spec, OptoFidelity, Solnil, and Actar. And altogether, this session will take 1 hour. And without further delay, I'd like to introduce the first speaker of this product release session, Sung-Hoon, the product managing director at ficonTEC. Welcome, Sung-Hoon.
Hello, thank you for the introduction.
Yeah,
My
whenever
name
you're
is...
ready, would love to hear about your new product.
Yes, thank you very much. Okay. All right, hello everyone. My name is Sung-Hoon Im. I'm the product management director at ficonTEC. Today, I'd like to introduce our industry-first, fully automated, double-sided wafer tester. So to begin, let's have a quick look at the evolution of optical datacom. So starting from the pluggable optics used in data centers, we are now at generation 4 3D CPO, co-packaged optics. So in 3D CPO, the optical engines or transceivers are placed on the same substrate right next to the central processing unit to eliminate bottlenecks caused by electrical path or cables or tracks. So this greatly increases the total overall data throughput. And this is our way, the industry's way to address the high demand of AI data centers bandwidth demand. So the heart of the 3D CPO lies in with this double-sided optical engine. So this is a micro transmitter and receiver, only about 15 millimeters long, and it has the photonics, electronics, and support structure with microplanes, all vertically integrated into this one chip. As you can see, the electrical contact or the bumps are on the bottom side, and the optical emission I/O faces the upside. So this is double-sided, one side optics, one side electrics. And if you look at the whole chip, this could be a GPU, CPU, or a switch. The optical engines, which on its own can deliver in the order of terabits per second of data throughput, can be placed around the central processing unit. And depending on how many that's around it, this can mean the overall aggregated throughput of this GPU, CPU, or switch can exceed 20 terabits, and even more if there are more optical engines placed on it. So if we have a look at how the optical engine is made, it starts with a thin PIC wafer. So this is the photonics wafer. Now, in the beginning, this is about standard 800 micron thickness, but the backside of it gets trimmed down and it becomes a very thin 100 micron PIC wafer. And on this, we attach the electronic IC, the support structure and lenses to become what's called a CUP wafer, compact universal photonics engine wafer. And then once it's diced, it becomes the optical engine. And if you look at the side profile schematics here, you'll see again, it has the PIC, EIC, and the support silicon on top, and the electric electrical contacts on the bottom, and the optical I/O faces the opposite direction. So here we face the challenge. So this is a double-sided optical engine, and conventionally the wafer level testing happened on one side only. So the wafer sits on a solid chuck, and the probing happens from the top side. Now we have a wafer that's double-sided. How do we test it on on the wafer itself? And ficonTEC has developed a new product from ground up to address this challenge. So in the picture here, you see that it is compatible with the industry standard ATE, automatic test equipment, that's shown in bluish color here, which does the electrical contact from the top side, and the ficonTEC prober machine on the bottom does the optical alignment from the bottom side, and the wafer sits somewhere in between, in the middle. If you and this tester can be configured with a wafer autoloader as well on the right bottom here, and it's a food wafer autoloader compatible with foundries, OHTs, the overhead transports for the wafer. So this is industry level fully automated solution that can be deployed to foundries. If you look inside the prober, it's not shown in the photo here, but on top of the photo will be the ATE head, and there'll be the probe card with probe pins in the middle here inside this red rectangle. And that'll be stationary, that doesn't move. The wafer table in the middle is floating. This moves with 4-axis motion, X, Y, Z, and rotation. And this moves from a die to die or device to device on the wafer, and it gets pushed up to the probe pins to mate, and it makes that electrical contact. Now, underneath the wafer table is the 6-axis optical probe alignment engine with 40 nanometer resolution motion. So this is a very fine alignment engine with the highest accuracy and precision, so that you can perform active alignment on the optical I/O part of the die on the wafer. Now it's easiest to understand if we look at a video of this machine in operation. So let me play this 1-minute video. So the key technologies that's making this a possibility is the specialty wafer chuck that we use, designed and use, and the FAU fiber array unit optical probe that's also custom designed. So the specialty chuck used here has slotted openings to allow the FAU to move in and approach the wafer through the chuck. And the FAU itself involves a very special technique. Now, to couple light into a grating coupler, you need to be at an insertion angle, specific insertion angle. But the way we tackle that is to 3D print an organic polymer material onto the FAU so that the 3D printed lens does the beam steering and focusing, So rather than the FAU needing to sit at the insertion angle, it can stay vertical and have the micro lenses do the beam steering. So having FAU, being able to put the FAU vertically allows us to have this enough space inside this opening through the chuck to move around for active alignment. Similar technology can be used for edge or trench coupling as well. We can do 3D periscope printed on the FAU to have the light emission horizontally onto the wafer. So this double-sided tester becomes a part of our test ecosystem, starting from the wafer inspection and laser cleaning to single-sided wafer test, double-sided wafer test, die level test, and even module level testing. So this completes our portfolio of products that ensures the CPO technology can be tested at various levels and become a success in the industry. So this is our industry first fully automated 3D CPO double-sided wafer tester, now possible with WLT D2. Thank you very much.
Very nice, Sung-Hoon. Nice product, great presentation. So we can have a very short Q&A session after each presentation. So if you have questions for Sung-Hoon, please push the raise hand button at the bottom of your Zoom screen, and I can pass you the word. In the meantime, I will ask myself, do you have any figures of merit Sung-Hoon that can show us like how faster is the testing done with this system as compared to some counterparts?
Well, great, but this is the industry first solution. So the first question would be, this is addressing something that was not possible before. The figure of merit, the UHT, things like that will come as a secondary question, and that is TBD. It's currently being the statistics needs to come in from our customers. So we'll save that question for later.
So the counterpart will be really to flipping the wafer and doing the test from scratch.
Not even that, because you do need to make the electrical contacts to excite the optics. So it's you need to do it simultaneously, and that's why it's been a challenge. And this, that's why this is a solution to the challenge.
Wow. Okay, I see. So this is a very unique station now.
Correct.
Okay. Well, thank you very much, Sung-Hoon, for highlighting this for us. I'm sure this will be a very successful product in future. I will
Thank you very
then
much.
thank you again and shift to the second speaker of today, Josua Zscheile, the CTO for software and co-founder of HETEROMERGE. And Joshua will talk about additive fabrication of functional 3D microstructures. Welcome, Joshua. Just unmute yourself.
Hello.
And you're
yes,
good to go.
That's what I was searching for. Thank you so much, Ivan, for the opportunity to speak today. I hope you see my screen share. Is that right?
Yes, you're good to go.
All right. Okay. So first of all, wait. Yeah, let me use some words about us. We are HETEROMERGE. We are a startup, a spin-off of the Technical University in Dresden, Germany. But we also have sales associates now in the US and in France for Southern Europe. And our core technology, just to get everyone on the same level, is in two-photon polymerization printing, where you use a laser of a specific wavelength to focus light on a very small spot, on a very small voxel inside a liquid monomer resin. And this laser spot will polymerize the resin on the spot, which in turn allows you to fabricate totally free-form 3D microstructures in the range of few micrometers up to a few millimeters. And in this 2PP ecosystem, we are specializing on using multiple materials in one print run. And how do we do this? Well, in situ, in the 2PP system, so 2PP just for two photon polymerization, we are actually exchanging the material where everything else, the printer and the substrate, stay static. And after this exchange, we can print again in the new material, which means in an automated fashion, we can totally precisely print objects of multiple materials. So with this printhead that we developed, you can produce all kinds of microstructures, but since we're in EPIC, I'm going to focus mostly on micro-optics. So here we have some examples of achromatic optics. You can also print optics with apertures, and you can print mechanical structures with rigid and flexible parts, all perfectly aligned and all while retaining all the benefits like the precision and the substrate independence of your two-photon systems. So what's actually new at HETEROMERGE? We recently developed or developed further our printhead to now incorporate a third material channel. And next to now being capable of using up to 4 materials in printing, our peer Pratyaj actually has published recently a study that shows that you can also use the system now to develop print parts while in print, or also your whole print. And we have some examples shown here. And what that allows you to do is to combine extremely heterogeneous materials in a precise and very efficient and robust fashion in a way that was not possible without this development step. And here are some examples of printing IP-PDMS, and so which is a soft material, and our rigid MX535 together. Also, yeah, with some fluorescence images. To summarize, we can produce compact optical systems or miniaturize existing systems with retaining the actual functionality of your 3D printed object. You have all the freedom of 2PP printing and more in terms of designs. As is usual with additive manufacturing, we allow for fast development cycles, fast prototyping, and also we are cost effective in the production up to medium quantities. So let me maybe focus a bit more on what we can do for our esteemed EPIC member colleagues. We have actually formalized our service into 3 steps, where with merge check, we want to comment and give advice swiftly on your concepts for printing micro-optics, and to confirm that what you have in mind can be done. With merge study, as usual, we we collaborate with you and print for you in a process from the idea to the finished 3D object that is to your specifications. And with merge scale, we help scale up the production, and we print for you small to medium batches of whatever you have in mind. So let me thank you again, dear Ivan and the EPIC team, and all of you for your attention, and I'm eager to await your questions.
Thank you very much, Joshua. Very exciting developments you do at HETEROMERGE, of course. So do we have any questions in the audience? Okay, I see we do actually. Sebastian from Alphamation, please go ahead.
Yes, hello. Thank you for the interesting talk. I do have a quick question. Maybe I missed it, but what is the minimum feature size you can print, minimum detail in an object?
Yeah, thank you for the question, Sebastian. So the usual feature size, I mean, it depends on the actual resin that you're using and on the print configuration, but the usual feature sizes if we're talking line width is around 200 nanometers.
Okay.
You can go smaller with some tricks, but that's the standard.
Yeah, rough idea. Okay, thank you.
Okay, thank you, Sebastian, for your question, and thanks again, Joshua, for a great presentation. We'll keep up with the agenda, and we shift to our next speaker, who will be Oliver Grass, and I believe supported by his colleague. They represent Inno-Spec.
That's me.
Hello, Oliver. And they will introduce the black eye, the black side of the sorting power.
Okay. So you should see it, right?
Yeah, it's coming in now, and the floor is yours.
I think I got the wrong one. How do I get out there now?
Okay, we see it now, but not on the full screen.
Yeah. It's always good to be prepared. Yeah, clearly. Yeah. So this should be better now. So can you see it right now?
No, we don't see it yet. No, it's a gray window we see instead. Now we see the corner of your presentation.
Das müssen wir einfach mal machen.
It is in
It's
PDF,
difficult
right?
if you don't work on your own laptop, so then you have no clue. Other way around. Ah, now that looks better. So is it now better?
Yes. So good.
Okay. So then let's talk a little quicker. Yeah, thank you to the EPIC team and the members for joining for an industrial presentation. I'm Oliver from Inno-Spec, the part of the HETEROMERGE group now, and today I would like to introduce you a new technology for tackle of one of the biggest blind spots in the recycling industry, how to finally see and sort black plastic. This is where we worked the last year on. So at Inno-Spec, we develop industrial hyperspectral solutions for recycling and quality control. And as part of the HETEROMERGE group, we bring together world-class optics, cameras, and machine learning tools. So our mission is to make materials visible and classify in real time directly on the production line. So the result is higher value, fewer mistakes, and more sustainable use of resources by combining cutting-edge technologies and optical designs. So what we enable to manufacturers and researchers is truly to understand their materials, and our solutions provide data which goes deeper than color, revealing composition, purity, and structure of every pixel. And this means this insight transforms production efficiency, supports process and optimization, and drives innovation across industries. So what's the problem? So why black plastic such a problem, and why they are so hard to detect? Because the reason is carbon black absorbs light in the near infrared, which is the most used range of most sorting cameras. And for the camera, a black item looks like nothing, like invisible. And this invisibility leads to mis-sorting, lower purity, and higher costs. So our solution is our answer, and let's hope that it works. that's our little teaser for black plastics. And our answer is the Black Eye Generation 2, a hyperspectral camera that works in the mid-wave infrared, which is a very critical wavelength region. And in this range, polymers reveal their unique chemical vibration, which means clear differentiation, even when the material is jet black. Black Eye Generation 2 brings the capability to industrial speed and scale, robust, stable, and ready for conveyor integration. What the product highlights. The key strengths includes high spectral fidelity with dense information across the whole mid-infrared range. It has a cool detector, which gives you a lot of signal stability, and the throughput especially is designed for conveyor belt applications. So open interfaces like GigaVision and SDKs making integration straightforward. So it's not only powerful in the lab, but it's also built for a real-world application set. And the applications are clear. Sorting black polymers in special PP, PE, and ABS is, especially for the Black Eye Generation 2, meant to replace near-infrared system, and it complements them. So it's not for replacing it. And think it as a filling gap for black and in existing lines. So compared to NIR-only setups, it achieves significantly higher purity in black fractions, unlock new revenues from what we use today by waste sorting. Beyond recycling, it applies to quality assurance and other dark or filled materials. So what is the news in generation 2? It, compared to the first generation, it delivers improved signal to noise and thermal stability, easier alignment and calibration, and more compact and service-friendly design. And with this tighter per-class integration, our software setup, built and developing models is faster than ever before. So the impact, what does it mean for the operators? Higher bail value thanks to cleaner black fractions, less manual rework and fewer rejects, and a retrofit pass. Existing lines can be updated to unlock black sorting without a full replacement, all backed by our application engineers and life cycles. So what do we do now? We would like to see in action that interested parties send us polymer mix and samples that we can measure them or demo them by us in-house or even at your site in the future, and to propose an integration plan with your region of interest estimated. So thank you for your attention and welcome to the dark side of sorting power.
Thank you very much, Oliver. Nice presentation and a great motto for your product as well.
Thanks.
So this is indeed a very impressive achievement in spectroscopy. I wonder if there are any questions from the audience. In the meantime, I also wonder myself, so does it still sort out all the other colors alongside with black?
It does, but it doesn't make so much sense. So because let's say the pricing of this mid-infrared cameras, of course, is higher. And of course, you need more value creation. So usually you use it in the end of sorting lines that you sort all other fractions before, quicker and faster. And in the end, you sort the more difficult materials like black plastics. But yes, it can see also the colored or white plastics. But just to use it like this usually makes no real sense in terms of value creation.
Sure. But at least it doesn't meet the other option. Okay, that's great. All right. If there is no further questions for Oliver, I suggest we thank them for a great presentation. And we move to our next speaker, representing OptoFidelity. And this is Ville Nummela, who will introduce Optocolor and elevating visual performance in prescription AR lens development. Welcome, Ville.
Thank you very much for the introduction. So yes, my name is Ville Nummela. I work for OptoFidelity. I'm a principal optical architect and a product owner for our
Ville, I'm afraid we lost the sound of you. Can you try now? No, we still don't hear you. So what you need to check is in the bottom left of the Zoom screen, you have the audio, and then there is a little arrow next to it. If you push on that arrow, you can choose the source of your microphone and the source of your speakers. So make sure you have the right microphone. Yeah, now I think it's good.
Okay, can you? Yes, now you can hear me. I don't know what happened because I was able to talk before just fine.
Okay.
All right.
Yeah, so maybe you need to start all over again.
Okay. I'll get started. Always something goes a little bit wrong in the beginning.
Okay, good.
Okay, cool. So thanks for the introduction. So my name is Ville Nummela, and I work for OptoFidelity. I'm a principal optical architect and a product owner for our instruments and their calibrations. And today I'll be talking about our latest instrument called OptoColor RX. First, really quickly about OptoFidelity. We are basically a metrology house. Typically, our solutions involve optics and robotics in some way. We have about 300 employees globally and close to 10,000 delivered systems around the world. Company was founded in around 2005 here in Tampere, and first products were test systems for phones and touch displays. Around 10 years ago, we started to expand to US and China, and then also introduced our first extended reality or XR product. Around 5 years ago, we really went on full on into AR VR world and introduced our waveguide image quality tester, now known as VGIQ, and this is really what the company is all about these days. So what's a waveguide? Well, here you see one on the left. It's basically a key component of the near-to-eye displays. It's the component that brings the light from the tiny little microprojector into the user's eye. It is also notoriously difficult to make, and testing solutions are most definitely needed. And to that end, we have been manufacturing various test systems into this market area. We have solutions from component to device level and R&D to mass production. The common denominator for all these image quality testers is the OptoColor family of measurement cameras. It comes in 3 versions: standard, grayscale, and the new RX version. All of them can measure a bunch of different metrics from the waveguide, most importantly maybe NTF, and the standard RX versions can also measure colors and the various uniformity metrics, all very important for the development of these waveguides. Now, OptoColor RX is basically just the same standard OptoColor, but it has an additional module, and that additional module allows you to add astigmatism into the optical part. Now, why on earth would you want astigmatism in your lens? It's a fairly simple answer. The motivation here is the need to miniaturize things. Early systems were, of course, big and bulky, and then everybody wants a nice, light, small form factors for their AR/VR displays. One of the many problems along the way is that our eyes are not the same. So like 60% of the people around that much need some kind of ophthalmic correction for near or farsightedness or astigmatism. And yes, this presents a problem for miniaturization because in addition to the waveguide, you need an additional lens directly in front of your eye. And if you're going for this kind of single lens form factor, then that's a bit of a problem. Now, the easy solution is, of course, that you can integrate the two. You just bond a prescription lens into the waveguide and off you go. But then there's one more challenge here, and that's the testing part. You still need to ensure the quality of the optics. How do you do that? Naturally, this extra lens will definitely mess up most testers on the market. And this is where the Optocolor RX comes in. So basically, the idea is that you just dial in whatever prescription you have in that extra lens. The device will compensate it away, and then you just measure normally. The standard version can do up to 6 diopters of spherical power and up to 4 diopters of astigmatism, and that's basically it. Below, I have also written some other key specifications. Have a look if you like, but that was my last slide. So if you have any questions, then please feel free to fire away. Thank you very much.
Thank you, Ville. Very interesting development indeed. Do we have any questions from the audience? I wonder, Ville, myself, if that's already on the market and how can this be tested by potential partners?
Well, we actually started making this already about a year ago, and we have several pilot customers already. It's actually already verified in production.
And are you open to serve more potential early implementers?
Well, I'm afraid most of them don't want their names in public, but there's only
but are you open to serve more new early implementers?
Yeah, sure, of course. I mean, it's a standard product now. We prefer to integrate it into testers. So if you're like a small to medium-sized manufacturer, we'll be happy to sell you some testers. Some large volume big players, they want to design their own testers, and we are also open to that business model. Of course, that requires a bit higher volumes.
Okay.
There's not that much competition yet in this market niche at the moment, so we are basically happy to work with everybody.
Okay. Thank you very much, Ville, once again, for a nice presentation and interesting product that we've seen. We shift now to the next speaker, that is Marco Abbarchi, representing Solnil. And Marco will talk about the inorganic and ultra-low refractive index SiO2. Welcome, Marco. Whenever you're ready.
Can you hear me?
Yes. The floor is yours.
Can you see the screen?
Indeed.
Okay. Thank you very much. To let us introduce our new product, AirCoat by Solnil, as a cladding layer for photonic metasurfaces and photonic integrated circuits. So first of all, Solnil is a spin-off of Marseille University, created in 2020, and today we have 12 people on a payroll. We're in the south of France. And our technology and products are based on inorganic resins that can be deposited by liquid deposition to form 2D coatings, or they can be directly printed in an edge-free nano-imprint lithography process to produce three-dimensional metasurfaces, or finally can be directly deposited onto three-dimensional metasurfaces, so they can be used as a cladding layer for three-dimensional objects. So our difference is that we provide materials with extreme properties, and the advantage is that we can do these with a much lower capital expenditure and lower cost of ownership with a greener process. Today, I want to introduce the AirCoat is a new generation of nanostructured material bridging dense and porous optical layers. It's basically composed of void and silicon dioxide, and it almost matches the refractive index of air because it has a refractive index of 1.12. So it is extremely low, but it has high optical quality. For example, the absorption is very low, below 0.03% across the visible spectrum, and the haze, which is associated to scattering, is well below 0.1%. This is comparable to the fused silica substrate. So you have a very low refractive index in a transparent and robust material and a process-compatible form. Here I show a few examples of application. Typically, we want to apply these to fill small nano cavities and to protect three-dimensional structure, for example, metasurfaces or photonic integrated circuits. The point here is that we produce this material on top of 3D structure with extremely low ripple. So, for example, this is very important because you can use these to deposit on top of a metasurface a second metasurface. This is the tendency of this community of stacking three-dimensional metasurfaces one on top of the other to add functionalities. So thanks to this flatness, you can use this product with a very low refractive index so to not perturb the properties of your metasurfaces or photonic integrated circuits, and with something which is extremely flat and transparent. Here I show some example of tests that have been done. For example, on 2 micrometer thick air coat, we measure the refractive index as a function of humidity. So from 5 to 95% humidity, the refractive index changes from 1.114 to 1.115 or a bit more, meaning that this material is water repellent. Like this property, we tested against thermal shock, humidity, UV light, adhesion, laser dicing, chemical resistance. All these features and much more have been assessed by our lead customer. So we have something that is ready to be integrated in your production lines. What is very important for a liquid resist that is transformed into a solid is the pot life. And here I'm showing that, for example, storing at 18 Celsius or 4 Celsius, you have a life well above 3 months. So it's easy storable in a conventional fridge for 3 months. So you have something which is highly stable upon time, as you have fixed processing condition in time and easy storage. And please contact us for further information, and I thank you for your attention.
Thank you very much, Marco. Great presentation and interesting developments for these microstructures. I see we have a question from the audience, from Sandro, Consorcio Centro, please.
Yes, Marco, two questions about this air coat. The first is, okay, is it possible to control relatively well the thickness of the layer? When you say, okay, is it possible to say, okay, 1 micron plus minus 100 nanometers is feasible or
Yes, yes, yes. The control is very fine. You can control better than 10 nanometers, basically.
Oh, okay, very good. And the other question is, how do you see it applied onto flexible substrates like Kapton also?
It's Kapton, I think it's okay. I don't remember the
400 degrees.
Yes, it's compatible with Kapton, definitely compatible with Kapton, yes. Basically, if you lower the processing temperature, because you have to anneal, of course, but if you lower the annealing temperature, you increase the annealing time, okay? So that's the compromise, but with Kapton is definitely doable and even below Kapton.
Okay, thank you. I'll contact you.
Thank you.
Great. We have another interesting question in the chat, Marco. can you sandwich the air coat between cement and glass?
Between what?
Cement and glass.
I don't know. We didn't try. It will be nice to try. My educated guess is yes. Yes.
Okay. So this is something you can maybe explore in the chat with the person who asked this. So we thank you again for the nice and interesting
Thank you.
demonstration there. And we switch to the last speaker of session today that represents Akhtar in ACM coatings. And this is Tamas Ref, material and mechanical lead at Akhtar.
Hi
And
everyone.
we'll talk
Good afternoon.
Okay. Hello, Tamas. Good to hear you. So you can put your presentation full screen and yeah,
Great.
we're good to go.
So thanks for having me, Ivan. Good afternoon, everyone. My name is Dr. Tamas Rev, and indeed I am representing ACM Coatings, which is a fully owned subsidiary of Akhtar. At Akhtar, if you haven't heard about us, we manufacture the world's blackest coatings. And just to be innovative, we also have white coatings as well. We have this mainly for two functions. So with the black coatings, obviously, we absorb stray light. So we suppress stray light, and our coatings can absorb from deep UV to far infrared about 99% of the electromagnetic broadband spectrum. And we can also tailor these coatings to have very functional different properties in their microstructure. And by that, we can change or tailor the solar absorptance and emissivity values. And with that, we can use it for cooling or heating, retaining heat, so passive thermal management. There are two ways that customers can work with us. They can send us a part, a complex 3D part that we can coat as a service, or we already have pre-coated thin films and foils available that are black or white, and they can come in various formats of films, sheets, rolls, die cuts, in case somebody wants a very complex geometry. And before I go into the actual new products, I wanted to show you kind of the optical performance of our coatings and just to talk a little bit about the coating itself, which kind of applies to both black and white a little bit. But in this case, I'm showing you the optical performance of our black coatings. So what you see here is a reflectivity in function of wavelength, and you see different Akhtar brands. Basically, they are all the same black coating. The difference between them is in their microstructure and also how they are designed for a specific wavelength range. So, for example, Magic Black, let me just, yes. So Magic Black would be the best optical, give you the best optical performance in the visible range, about 1% reflection, and also in deep UV applications. So semiconductor industries and let's say space applications, star trackers, they all use Magic Black. If you're looking for something a bit more robust, a bit more durability in terms of the coating, then we have Vacuum Black, which goes into the near infrared spectra. This coating can really support ultra high vacuum applications, and also in applications in the semiconductor industries or where conductivity or tailoring conductivity is essential. We have Fractal Black, which has a very broadband absorption up to 10 microns, and this is one of our best seller in space applications. This is what we have used to coat the James Webb Space Telescope and at least 43 other space missions. And also we have Ultra Black. Ultra Black can help you absorb far infrared light. So you can see on the screen here up to 15 microns, but it can actually go up to 50 or even 100 microns. And because of the differences how we tailor the coatings, they have a variability in their thicknesses, but they all possess extremely low thickness, so in the range of microns, basically. So why customers come to us? I'll give you 10 reasons why. Basically, as I mentioned, our coatings are black coatings. I'm talking about black, 99% absorbing in a very, very wide broadband range in the electromagnetic spectrum. They are extremely low outgassing. In fact, ESA has chosen us as a reference material on the EMA mission to the International Space Station. Our coatings are thermally stable, so between minus 290 degrees Celsius to 450 degrees Celsius, they are completely qualified. we can literally coat any substrate. So if you're looking at the most popular ones, metals, glass, ceramics, these are the most common ones, but we can also do polymers and composites. The limitation for our coatings is usually the lower temperature. So we cannot go below 80 degrees Celsius in our processes. And just to mention that all of our coatings are deposited in a vacuum chamber. As I mentioned, all of our coatings are very, very, very thin, and they don't have any negligible particulation, and they are also high vibration stability. In terms of their abrasion resistance, we have variability. We have from light to medium to moderate, moderate plus in terms of how much they are resistant. But generally speaking, they are resistant to solvents. So any traditional solvent like IPA, acetone, ethanol, you can gently wipe, clean, rinse, even ultrasonic cleaning is fine. Our technology and our coatings are REACH and RoHS compliant, and they are ecologically clean, the processes. And we can also tailor the coatings surface resistivity. Generally speaking, we are in the static dissipative range, but we can tailor it to be less or more conductive on either end of that range. And if you're not satisfied with the outcome, we can take off the coating and put it back on. So with that, I want to introduce you one of our new coating types for these directly applied coatings, which is called Actar Core Black. So Actar Core Black is actually a new coating which is especially designed for wafer chucks and component mounting. So you can see a wafer chuck here and the silicon wafer here. As we know, wafer chucks should be extremely flat, especially in order to avoid bending the chip, to avoid defects in the manufacturing processes, and to ensure a uniform layer deposition. They also have to be abrasion resistant, especially because wafers are being constantly loaded, unloaded. It makes the surface less flat, less black, and it harms the vacuum that holds the sample in place. So with that in mind, we have designed Core Black, which has exceptional durability. It ensures a flatness of about 2-3 microns on the surface of the coating. Generally speaking, it is less black than our usual black coatings, but it also possesses an ultra high cleanliness level. So molecular contamination would be about 1 nanogram per square centimeter, and the pack value would be below 30 ppm. So what you see here is the actual total hemispherical reflectance average graph in the visible range. So you can see between 0.4 and 1.6 microns, you can see the optical performance of this coating. Another product that I would like to introduce is Actar Diffusive Mirror Foil. And I will start with talking about Spectralon, which is a very highly reflective diffusive white material. We use it to calibrate optical instruments, and it has a very high, over 99% reflectance across UV near-infrared range. It is made out of PTFE, which is commonly called Teflon. Now, Teflon is problematic environmentally. It can last hundreds to thousands of years without breaking down. And the manufacturing processes include PFAS, which is a chemical that have been linked to cancer, hormonal disruption, immune system effects, and all kinds of environmental contaminations. And also harmful gases are released into the atmosphere during manufacturing. So worldwide, there is an increasing pressure, demand, whatever we want to call it, but to limit and find alternative to these PTFE and PFAS substances. So in the EU and Canada, we want to ban the usage of PTFE. And in the US, some states are already banning the usage of PFAS chemicals in consumer products. So with that in mind, we've designed, we pre-coated a thin film or foil, which is called Actar Diffusive Mirror Foil. It's for optical testing and calibration. It does have a nearly ideal Lambertian type of diffuse reflectance across a wide spectral range. So it provides a REACH and RoHS compliant alternative to PFAS materials. And as you can see on the optical graphs here, the total hemispherical reflectance, it exceeds about 90% from here in the visible range, so 0.4 to 17 microns. And this is provided with a spectrally flat response across these regions. The coating itself is deposited on a stainless steel foil. The thickness of the coating is less than 5 microns or below 5 microns, and the weight is 1 microgram per square centimeter. Nonetheless, I have to say that all of our coatings are 100% inorganic, just as this diffusive mirror foil and Actar Core Black as well. And in terms of electrostatic discharge, it is ESD safe, and the surface resistivity is in the dissipative range. Thank you very much, and I'm happy to take any questions you may have.
Thank you very much, Tamas. Great presentation and nice variety of products Actar can offer. Any questions from the audience? Okay, we have Sebastian from Alphamation. Go ahead.
Yes, hello. Very interesting product. Also, the white coating is very interesting. Is it available also, like the black one, as a service coating for parts and also foils in both versions, let's say?
So the white coatings I've presented here is not related to passive thermal management. It is more like for diffuse reflection for calibration purposes. But we do have a range of white products that we offer, so I can help you with that if you send me an email or if you contact us. Generally speaking, our white coatings are more commonly available on foils at the moment, but case by case, we do have as a service. So we do have provided white coatings as a service as well. It depends on, again, your application and many other requirements.
Okay. Thank you. Good to know. Thank you.
Okay, nice. Well, thanks again, Tamas, for showing us all these impressive products of Actar, and thanks again to everyone who presented this product release of EPIC that we have today. So you now have this little poll to give us feedback about the meeting. I hope you enjoyed it as much as I did. I'll also share a few quick messages with you. So thanks for joining our meeting today, and thanks again to all the presenters of this session. EPIC is there to support you with technology expertise, market reports, and opportunities in networking, mentorship, and investment. I'd like to thank the team of EPIC who made this meeting possible, and I'd also like to invite you to our upcoming offline event that will take place on 17th of November in Munich, alongside with the Semicon Europe Expo, and we will do this meeting dedicated to bridging the photonics and microelectronics communities. We have a very nice lineup of speakers and interesting agenda, including the visit to the Atacube company there in Munich. So please save the date of 17th of November and consider joining us there. So hopefully see you in Munich, and thanks for joining this online event, and see you on the next occasion. Goodbye, everyone.
Bye-bye.
Thank you, everyone. Thanks, everyone, for joining. The room will stay open